Today we're going to continue with more examples on graphing polynomial functions. Up top I added some notes that we talked about in yesterday's video. If it's an odd degree polynomial, the ends of your graph are going to go in opposite directions. If you have an even degree on your polynomial, the ends of your graph are going to go in the same direction. And then remember that the range is different. If the a is negative, that lets us know that the graph opens down. So in the first four examples, it says, do a rough sketch of the given polynomial, state the domain and the range in interval notation, and state the end behavior. All right, so roughly sketching. So I'll make my table. Odd degree polynomials look like cubic functions. Even degree polynomials look like quadratics. So the a is +1. It's an odd degree, so I know the ends are going to go in opposite directions. So a rough sketch looks like that. Okay. So now I want to state my domain. So my domain using interval notation. Okay. Remember from yesterday's lesson that the domain for every polynomial, whatever the degree is, the domain is always -infinity to +infinity. The range is only different if it is an even degree. Ours is not even, so the range is also -infinity to +infinity. Remember, domain is saying, what's your graph doing left and right? Well, it's going right forever and it's going left forever. Range is the y values. It's going up forever and it's going down forever. So then it says, also state the end behavior. So as my x's are going to +infinity, which means as I'm going to the right, our graph is going up. So the y's are going up. Now as my x's go to -infinity, so as I'm going this way, the graph is going down. So the y values are going to -infinity. Okay, looking at this next example, f of x equals -x⁹. So first of all, the a is negative. That tells me the graph is opening down. And it's an odd degree, so the ends should be going in opposite directions. And odd degrees look like cubics. You can make a little side note to yourself about that as well. Okay, so odd degrees look like cubics. And this is just for the parent functions. So it's going to go down, and the ends are going in opposite directions. So again, if I want to state the domain for polynomials is always -infinity to +infinity. The range is the same unless it's an even degree, which it's not. All right, now if I want to talk about my end behavior, talk about where those arrows are going. So as the x's are going to +infinity. So as I'm going to +infinity on the x-axis, our graph is going down. So the y values are going down. As my x's are approaching -infinity, so as I'm going this way, the y is going up. The arrow is going up. Okay, so the end behavior should be going in opposite directions, like we have stated up here. All right, let me skip example 3 and let's look at example 4. Negative tells me the graph is opening down. Even degree tells me that it is going to be in the same direction. So even degrees look like quadratics. So we can write that as a little side note. And again, this is just quadratics, just parent functions. So the even degrees look like quadratics. So I'm going to draw a quadratic but have it going down. Okay, so rough sketch. So now I want to state the domain. So again, every polynomial, no matter what the degree is, the domain is negative infinity to positive infinity. However, the range is different for even degrees. So the range is you describing the y values. Is this graph opening up forever? So is it going to go up forever? No. Okay, it is not going beyond this line, which is y equals 0. Is it going down forever? Yes, these are going down forever. So remember, with interval notation, it's the biggest number. So 0 is the large number. Actually, I just said that wrong. Excuse me. Smallest number first, then the largest number. So our y values are going to negative infinity, and then their highest value is 0. So I need to say that differently. So we're going to say, I'm going to make that a negative infinity. So negative infinity is the smallest y value, and it's going up to 0. Since we're plotted at 0, that's a bracket. You can use a parenthesis on the infinity because you can never reach it. Okay, now let's talk about something different. From your in-person, your notes, I said that weird, I'm sorry. So yesterday, in-person students got this packet. Those of you that are 100% remote, this is just from your online textbook. You don't necessarily need to write it down. It doesn't hurt to. But they're going to go ahead and they're going to give us a polynomial function. They're going to have it in factored form or intercept form. Okay, so here's an intercept, here's an intercept, here's an intercept. Remember, you can find the intercepts by setting these factors equal to 0. Now, we have a couple things that we have to pay attention to. Sometimes our graph will cross the x-axis at the x-intercept. However, the graph can also be tangent to the x-axis. And what that means is the point of tangency becomes a turning point. All right, so what that means basically is if it's going to be tangent, then we're not going to pass through the x-intercept. We're actually going to like bounce off of it. So I'm going to give you a few little post-it notes here just so we know what we're doing. To find an x-intercept, you're going to set each factor of x equal to 0, and you're going to solve it. You guys have already done this before, so this is not difficult. I highly recommend that you write this down. If the factor that produces the x-intercept is raised to an odd power, then the graph is going to cross, which means it's going to pass through the x-intercept. If the factor that produces an x-intercept is raised to an even power, the graph is going to be tangent. And basically, tangent just means it's turning away from the x-intercept. So it's not going to go through the x-intercept. It will like bounce off of it. Okay? So make sure you have these written down for sure. All right. So now looking at these next couple examples. Let's see, I'll put this, throw that one there too. I'll just bring it back if I need it, sorry. Okay, so it says state if it's an even degree or if it's an odd degree polynomial. So you want to see how many x's you have. So here's an x, here's another x, here's another x. So I have an x, another x, and then I have another x. So this is a third degree polynomial. Or cubic, if you should say it like that. So now I want to find the x-intercept. So wherever there's a factor of x, I'm going to set it equal to 0. So I'm going to take this factor and set it equal to 0. I'm going to take this factor and set it equal to 0. And I'm going to take this factor and set it equal to 0. Okay, so here's an x-intercept. I'm going to solve this one. What number plus 1 is 0? Negative 1. So I have an x-intercept at negative 1 as well. What number plus 3 is 0? Negative 3. All right, so now you also need to state if it's going to cross the x-intercept or if it's going to be tangent. So looking up here, I want to look at the power. So on the x, this is an x to the first. Because that is an odd power, the graph is going to cross the x-intercept. So this crosses. If I look at this factor This factor is also raised to the first power. So because 1 is an odd number, it's also going to cross the x-axis. And we'll deal with graphing in just a second. X plus 3 is also raised to the first, which is an odd number. And odd numbers for the exponents tell us that we are going to cross through the x-intercept. Okay. Looking at this one, this is an x plus 1 squared. So technically I have two x's here. So I have an x squared on this one. There's only one x on this factor. There's only one x on that factor. So total this is 4 x's. So it's a 4th degree polynomial. Okay. Now I want to take each factor and set it equal to 0. So I've got x plus 1, and I'm going to set it equal to 0. And then I'm going to take the x minus 1 and set it equal to 0, and the x minus 2 and set it equal to 0. What number plus 1 is 0? Negative 1. What number minus 1 is 0? Positive 1. What number minus 2 is 0? Positive 2. So I have an x-intercept at negative 1, I have an x-intercept at positive 1, and I have an x-intercept at 2. Now we need to state if we're going to cross through that x-intercept or if we're going to be tangent. So on this first factor, it was raised to an even degree. So if it's even, then we know that we're going to be tangent. Okay. If I look at this factor, it is a first degree. So since I have a first degree, it's an odd number. So we're going to cross through that x-intercept in just a minute. Okay. X minus 2 is raised to the first, which is an odd number. So we're going to cross through. All right. Let's try one more. Okay. So figure out the degree. Here's an x. An x minus 2 squared means there's actually 2 of these x's, which total is 3x. So it's a 3rd degree polynomial. And I'm going to take each factor and set it equal to 0. Okay. So solving that would still give me a 0. Solving this one, what number minus 2 is 0? 2. Okay, so I have an x-intercept at 0. I have an x-intercept at 2. Now look at the exponents. On this first factor, it was raised to the first, which is an odd number. So it's going to cross. Okay. However, the x minus 2 was raised to the 2nd power, and if it's an even power, it's going to be tangent. Okay. I'm going to skip example 8. And now we're going to start applying this. So we're going to do a rough sketch. So first of all, I want to figure out what's the degree of the polynomial. Okay, well here's 1x. So there's an x to the first. There's an x squared, and there's an x to the first. So that makes this a 4th degree polynomial. All right. And it is a positive because I have a positive x. Here's another positive x squared. Here would be another positive x. So it is a 4th degree polynomial, which tells me that the ends are going to be going in the same direction. So I'm going to go ahead and just put that here. And I told you guys yesterday that once they start adding more to the parent function, which there's a lot more stuff here, it changes the shape of the inside of the graph. So we're just going to do the best that we can. I know that the ends have to go up in the same direction because it's an even degree and the a is positive. Now I need to figure out my x-intercepts. Okay, so I'm going to take each factor and set it equal to 0. So x set equal to 0. If I take this and set it equal to 0, what number plus 2 is 0? That's negative 2. What number minus 1 is 0? That's positive 1. So I know I have an x-intercept at 0. I know I have an x-intercept at -2, and I know that I have an x-intercept at 1. Now we also need to determine, are we crossing through these or are we going to be tangent? So on the x, it's to the first, so that tells me I'm going to cross through that x-intercept. This x plus 2 is raised to the second power. So if it's to an even power, we're going to be tangent to that intercept. Okay, and then this is raised to the first. So that's an odd number, so that lets me know I'm going to cross through that intercept. So at the -2, I'm going to be tangent. So -2 is my first one. So I know I can't go through it, so I got to bounce up. I know that I have to then pass through or cross the 0, and then I also have to cross through the 1 and end up here. So I'm going to just bend this back. I crossed through the 0. I know I have to come back and cross through this and end up here. Rough sketch, that's all I'm going for, not perfection. This could possibly go up higher. I don't know, and I don't really care right now because we're just doing rough sketches, okay? So you guys could vary that a little bit, but it does have to bounce off of that and does have to cross through that intercept and cross through, and the end behavior still has to be the same, okay? So here, they're showing me that I have a negative for my A, so that tells me that the graph is going to open down. The A is negative. All right, here I'm going to have an x-intercept. What number plus 1 is 0? -1. Or you guys could just say it's the opposite. Here I'm going to have an x-intercept. Change the sign. At 2. Here I'm going to have an x-intercept at 3. So we have an x-intercept at -1, 2, and 3. Okay. Now, you also need to tell me what degree of a polynomial is. Here, there's only one factor of x. Here's one factor of that x, and one factor of that x. So I have an x, another x, and an x. So this is a third degree polynomial, which tells me that the ends are going in opposite directions. Okay, so, and I know the ends have to go in a downward motion. So opposite directions. The ends are in opposite directions, and that is a negative. We need to figure, are we crossing these? Are we going to be tangent to them? So this is a first degree, which is an odd number, so I'm going to cross. This is a first degree, and that's a first degree. So we're crossing through each of these intercepts. Okay, so we're crossing through this one. I got to come back up and cross through this one. I got to turn back around and cross through that one so that my ends go in opposite directions. Okay, let's try one more. First of all, I want to figure out the degree. So here's an x squared times an x. That makes this a cubic. The A is positive, so the graph is opening up for this odd degree. So I know odd degrees go in opposite directions, and this is a positive direction. Okay, figure out your intercepts. Okay, so take x squared and set it equal to 0. That tells me I have an x-intercept at 0. Take x minus 2 and set it equal to 0. That gives me a solution of 2. So I have another x-intercept at 2. Now, the degree on the x squared was even, so that tells me that we have to be tangent. I'm just going to abbreviate that. This degree is 1, which is odd, so that tells me that I'm going to have to cross. So I have to be tangent to the 0, but I have to cross through the 2, and I got to make sure that my ends still go in the right direction. So we're going to come from here. I'm going to go to my first intercept, but I got to be tangent, so I can't go through it, so I'm going to have to bounce off of it. But I know that I do have to cross back through here and end up this way. So I'm going to turn it back and cross it through. It does not have to be perfect. Okay? This could possibly dip down further. This could actually be a little bit steeper. but we're just going for rough sketches. Okay, let's look at this one. We're going to write a cubic function, so I know it has to be an x to the third. And it's going to say, assume that the constant of a is either 1 or negative 1. Well, for this one, it's going in a positive direction, so I know that the a has to be positive 1 for this problem. This is going down, so I know for this problem, the a is negative 1. Okay. Now, I have an x-intercept here at negative 3, so I'm going to mark that down. I have an x-intercept at negative 1. And I have an x-intercept at positive 1. And they're all crossing through, so that tells me the degrees have to be odd. So I'm going to say y equals, our a is 1. The factor that would have given me this solution, plugging it into a parenthesis, it's going to change its sign. Okay, so there's my x plus 3. I'm going to change the sign on that one. And I'm going to change the sign on that one. Now, would this give me a cubic function? This is an x to the first, that's an x to the first, that's an x to the first, which would give me my 3 x's to make it a cubic. Okay. Looking at this one, I know I have an x-intercept at negative 2, and I have another x-intercept at 3. All right, let's look at our equation. So we're going to say y equals, our a is negative. I know I'm going to have a factor of x plus 2 and a factor of x minus 3. However, we were tangent to the negative 2, which means I have to have a even degree on here. Plus, I have to make it a cubic, and right now I just have 2 x's. But if I turn this to a square, which is an even number, hence the tangent, now I have 2 x's here and 1 x there, which now gives me the cubic. Okay. Looking at a quartic is a 4th degree, so I got to make sure that my final answer, that there are 4 x's. It's opening up, so I know that the a is positive. This one is opening down, so I know that this a is negative. I know that I have an x-intercept at negative 3. I have another one here at 0. I have another one at 2. And another one at 4. Here I have an x-intercept at negative 2. And I have another one at 3. So now if I want to write my equation, I'm going to say y equals our a, 1, times, I'm going to have a factor of x plus 3. It's always a sign change. You could say x plus 0 if you wanted to, or just say x. Change the sign. I'm going to have a factor of x minus 2, and I'm going to have a factor of x minus 4. And then I want to make sure that I have 4 x's. So here's an x to the first, an x to the first, an x to the first, x to the first, which gives me 4. Looking at this one, I can say y equals, our a is negative since it opened down. I know I have a factor of x plus 2 and x, change it, minus 3. However, this is only 2 x's, and I need to make it a quartic, which is 4, plus these were tangent. That means I need to have even degrees here. So I need 2 even numbers that are going to give me a 4. Now I have 2 x's there and an even power. I have 2 x's here and an even power. So I have 4 x's total, making it quartic. And their even power is telling me that it's tangent.